Okay, this video just builds on our previous video about inverse trigonometry, and we're going to tackle some more complicated style problems. Recall in the previous video that when we had kind of like a composite function, sort of like we had sine of inverse sine of something, the two functions, they matched. We had sine and inverse sine. So what happens if they don't match? We have a mismatch here, right? Cosine of the inverse sine of root 2 over 2. So the way to approach this problem would be to kind of work your way from the inside out. So we're going to look at what's inside here, which is the sine of the square root of 2 over 2, sine inverse, square root of 2 over 2. We know that this is talking about some angle. Remember, the question we ask ourselves is sine of what angle gives me the square root of 2 over 2? You can say that this is 45 degrees, or it's pi over 4. Now, you need to have knowledge of the unit circle in order to get some of these values, especially if they're, these kind of strange values. It's possible that they're not these values, and we'll show you how to do those too. But now, if you just write cosine of 45 degrees, or cosine or cosine of pi over 4, either way, you'll find that this is just the square root of 2 over 2. So the answer to this one is the square root of 2 over 2. It kind of works like they canceled out, but that's only because sine and cosine are both the square root of 2 over 2 at 45 degrees. Let's look at another one. Okay, so here's one that's totally mismatching, right? Tangent of inverse cosine of negative square root of 3 over 2. So again, work your way from the inside out. So we're going to look at this. Cosine of what angle gives me negative square root 3 over 2? Now when you're doing this, remember about the range of inverse cosine. So what possible angles could come out of this? Because there's many answers to the question of cosine of what angle gives me negative root 3 over 2, but there's only one that's inside the range that we want here, and that is what is that, 5 pi over 6. Okay, so what I'm thinking when I'm asking myself that question is, all right, I need my negative root 3 over 2, which is over here, right? That is my negative, that's my pi over 6 reference angle in quadrant 2, which is 5 pi over 6. 5 pi over 6 does come out of the inverse cosine function. So tangent of 5 pi over 6, what's that? Okay, well now, this doesn't matter, right? This is just asking for tangent. 5 pi over 6, tangent doesn't have, tangent's domain restrictions are normal domain restrictions, where we can't have pi over 2, 3 pi over 2, etc. So what is the tangent of 5 pi over 6? The tangent of 5 pi over 6 is negative square root 3 divided by 3. Okay, let's do the next one, another one. Okay, here we go. A sine of inverse tangent of negative 1. Inverse tangent of negative 1. When is tangent negative 1? Well, tangent is negative 1 at negative pi over 4. So think about that. Tangent is 1 here, it's negative 1 there, it's 1 there, it's negative 1 there. So it's negative 1 both here and here. But remember, we said our range, our possible allowable outputs for tangent are only between negative pi over 2 and positive pi over 2. So our answer then is negative pi over 4. And then what is the sine of negative pi over 4? Well, that's just negative square root 2 over 2. Okay, let's see, what's next? Okay, sorry, I pushed the wrong button. There we go. Okay, so now this one's different. Okay, so now we want the cotangent of the inverse sine of negative 4/5. Well, we don't know what the inverse sine of negative 4/5 is, but what we do know is that this is a ratio of side lengths of a triangle, and that this whole thing, when taken as a whole, is talking about an angle. This is talking about a triangle, so we can draw that triangle. Now I'm going to introduce a hashtag for you here. It's called hashtag DTFT. Okay, I put it on Twitter, make it trending. It stands for draw the, and then you leave it to your imagination what the F means, and then triangle. Draw the triangle. Draw that triangle. Okay. If you draw the triangle, if you get used to drawing the triangle in the correct orientation, you will be able to solve so many of the problems that we're going to come across in this chapter. Okay, so what does this mean, draw the triangle? Well, draw the triangle. Okay, and it's sine. Okay, remember that sine inverse sine has to come out in quadrants, either quadrants 1 or 4, but I have this ratio of side lengths where it's the opposite side, because this is opposite, this is hypotenuse, that means that this opposite side here is 4, this is 5, which means this is 3. So I've just drawn that triangle. Now I don't care what theta is, because this question is asking me what is the cotangent of theta. Now I don't need to know what theta is if I know all the sides of the triangle. So cotangent, remember, cotangent of theta is equal to 1 divided by the tangent of theta, or another way to say that is the cotangent of theta is equal to, whereas tangent is opposite over adjacent, is adjacent over hypotenuse, right? So adjacent is 3, sorry, not hypotenuse, opposite over adjacent, adjacent over opposite, I'm sorry. So it's 3, the adjacent, divided by negative 4. So the answer to this one is negative 3/4. Okay, draw the triangle. Okay, here's another one. Now this is not a standard unit circle-y thing, so we need a DTFT, hashtag DTFT. So we're talking about a triangle here. It's positive, so it's got to be in quadrant 1. The opposite side is 2 root 5, and the hypotenuse is 5. So we want to figure out what this guy is, and we can do that using the Pythagorean theorem, right? So we could say that this, if we call that A, that B, and that C, you say 2 times the square root of 5 squared plus B squared, I don't know, equals 25. And then 2 root 5, right? So let's fix this. B squared is equal to 25 minus 2 root 5 squared. B squared is equal to, okay, so what is 2 root 5? 2 root 5 is 4 times 5. So 25 minus 20, B squared is equal to 5. The absolute value of B is going to equal the square root of 5, so B is equal to plus or minus 5. But since we know we're plus or minus square root of 5, but since we know we're in this quadrant where this B value is positive square root 5, now we know the sides of that triangle. There's your theta. Secant, remember, secant of theta is 1 divided by the cosine of theta. So whereas cosine is adjacent divided by hypotenuse, secant is hypotenuse divided by adjacent. So we're at secant would that be negative root 5, sorry, it'd be square root of 5, it would be 5 divided by the square root of 5, right? So this would be 5 divided by the square root of 5, we multiply it by the square root of 5 over 5, that's rationalizing, this just ends up being the square root of 5. Okay, there's our answer. Alright, another one, so this one you don't quite have to draw the triangle, right? Cosine inverse of the square root of 3 over 3. Okay, so what is, oh wait, yeah, we do actually, this one's a little weird. Okay, so cosine inverse is square root of 3 over 3. Let's draw this triangle. We have negative cosine, so it's going to be over in this quadrant. And the opposite side is, so we can draw this a couple different ways. We're given negative root 3 over 3. That is in the form of adjacent divided by hypotenuse, right? So that means this is 3 and this is negative square root of 3. And so I want to know what this side is because I need that in order to get the cotangent. So again, we'd say it's negative square root of 3 squared plus b squared is equal to 3 squared. So b squared is equal to 3 squared minus the negative square root 3 of squared, the negative root 3 squared. So b squared is equal to 9 minus 3. So b squared is equal to 6. So b is equal to the square root of 6. Okay, so that's square root of 6 over there. And then we want the cotangent, which cotangent of theta, cotangent is equal to the adjacent divided by the opposite, right? So adjacent of this angle theta is negative root 3. So we have negative root 3 divided by the opposite of square root of 6. We do a rationalization here. We do a rationalization here. That's a 6. Handwriting is off the rails today. This is negative square root of 18 divided by 6. That's, if you take 3 out, that's 3 times the square root of 2, negative divided by 6. So this simplifies down to negative square root of 2 divided by 2. So there we go. that is the cotangent of inverse cosine of negative root 3 over 3. Here's another. This one we need to draw. We need to DTFT. This is talking about a triangle inside here. It's a triangle. Ooh, that was supposed to be one of those braces. That's a triangle. So it's tangent 4/3. Tangent's positive over here. So the opposite side is 4. The adjacent side is 3. We know hypotenuse is going to be 5. That's theta. What is the cosecant of that angle theta? Well, cosecant is hypotenuse divided by opposite, right? It's the inverse. It's not the inverse. It's the reciprocal of sine. So this is just going to be 5/4. That's the hypotenuse, because cosecant theta is the hypotenuse divided by the opposite. Okay, so 5/4. All right, let's do another one. Okay, so this one's a little bit different now. We want to work our way from the inside out. Now you can't, it's very tempting to say that this is negative 7 pi over 6. Okay, but we have to be careful about what we're allowed to plug in to the inverse sine function, or what this could possibly be. So first of all, what is this? We know this from the unit circle. This is going to be negative 1/2. Okay, so now it's saying sine inverse of negative 1/2. We can plug that into sine inverse, that's fine. But while the answer to the question of what angle of sine gives me negative, sine of what angle gives me negative 1/2, there are infinitely many correct answers to that. There's only one that will pop out of an inverse trig function. It's the one that's in the range of the inverse trig function. Remember, when we talk about sine is okay from negative pi over 2 to positive pi over 2. So in this range of angles, where it is negative 1/2, sorry, it's not there, it's right there, which this angle is, sorry, that shouldn't be negative 1/2. This should be, oh, I did this completely wrong. I'm sorry, negative 7 pi over 6 is over here, right? So this should be positive 1/2. So sine positive 1/2, we're talking about this angle right there, not the other angle. So that is positive pi over 6, or 30 degrees. Okay, so now we want secant inverse of secant of negative 2. Okay, so this one's a little tricky, right? I don't have a button for inverse secant or anything, but I can still draw this triangle, right? Because negative 2 is still talking about side lengths, and this is in the form of hypotenuse divided by adjacent. So if negative 2 is equal to the hypotenuse divided by adjacent, I could just say the adjacent side is 1. Let's draw this. We're negative cosine, right? So we're talking about cosine. The secant and cosine are related. So we need to draw this like this, right? Where this is going to be 2 and this is going to be our negative 1. That's going to give me, so really it wasn't the negative, it wasn't the 2 that was negative, it's the 1 that's negative. Still just negative 2. All right, so if that's the case then, well, what does this one have to be? Well, let's see. I mean, I'm not sure. Let's see. This is b squared, right? So negative 1 squared plus b squared is equal to 4. So b squared is equal to 4 minus 1. So b squared is equal to 3. So b is equal to the square root of 3. So that's the square root of 3 over there. And now we want, what angle is that, right? Well, what triangle does this remind you of here? If you were to normalize this, if we're to divide all these things by 2, if we divide all these by 2, right, we'd have a hypotenuse of 1, a adjacent side of 1/2, negative 1/2, and an opposite side of root 3 over 2. Hey, look, that's a 60-degree reference angle in quadrant 2, so that is an angle of 2 pi over 3. So 2 pi over 3, or 120 degrees, either one. Okay. Right, there's some that we just can't do without a calculator. So this would be an example of one that we have to use a calculator for. And the button on the calculator is simply when you hit second and then you hit sine. So second sine gives you this inverse sine. Oh, I didn't hit second, sorry. Second sine. Okay, now we can type in our negative 0.78. Like, is negative 0.78 in the domain of inverse sine function? Yeah, it is. Anything between 1 and negative 1, including 1 and negative 1. So if you hit enter on this, you get negative 51 0.26, and this is in degrees because we're in degrees mode right now. So if the question wants degrees, then you give degrees. If you want radians, you need to change your calculator to radian mode, and you can redo that calculation, and you'll get, that's the same thing as negative, what was it? Negative 0.89 radians. Okay, radians. You don't have to write radians. It's just given. If there's no unit, it's radians. If there's no degree sign, it's radians. If it's talking about an angle. Okay, now this one here is real tricky because we don't have an inverse secant button, right? We have inverse cosine though. So something that we need to recognize here is that this is in the form of, that's a ratio of sides. It's in the form of hypotenuse divided by adjacent. So if I want this to like flip around and become adjacent divided by hypotenuse, well then I would have this, I'm be talking about the same triangle, the same angle is in here, okay? Now, this isn't an angle, this is a ratio of sides, but it's the ratio of sides from the same triangle, so it's referencing the same angle, and now I would want cosine inverse so I'd want cosine inverse of this. So that kind of, hopefully that made some sense, but basically what I'm saying is instead of 2.7904, I'm going to put 1 divided by 2.7904, and I'm going to say cosine inverse of this is equal to our original question of 2.7904. So you're going to have to get a little bit, you have to get a little clever, you have to outsmart your calculator here. So when we do this one, we've got, and I'll just do this in radians, I guess. So we would have cosine inverse, so inverse cosine, second cosine, of 1 divided by 2.7904. And that gives me a radians of 1.204 radians. So 1.204, and I'll just put radians here just to be clear, but doesn't have a units. And then in degrees, it's whatever it would be in degrees. Let's see. We just change it back to degrees really quick. Okay. And then redo the calculation. And it's 69 degrees. 69 degrees. Oh wow, I wonder who wrote that question. Alright, that's it. That is fairly advanced inverse trig. These concepts will carry through. Draw the triangle. There will come a time when we start talking about sum and difference of angles where you'll be like, wow, it's a good thing I got in the habit of drawing the little triangles associated with inverse trig, because boy oh boy is it going to come up again.